Last lesson you had a look at the different types of precipitation. Today we're going to think about excess runoff in the water cycle. To begin with, we just need to think about what we mean by runoff. Runoff is this idea of water flowing over the ground, and it can be caused in different ways. To begin with, we'll talk about prolonged precipitation. So this is where you get rainfall or snow or hail for a very long period of time. Think about the weather that we had in Sheffield through the autumn and into the winter, where we had very high levels of rainfall. And what happened was we got something called saturation excess overland flow. This means that the ground is so full of water that it can't hold anymore. And when you get more rainfall week after week after week, what will happen eventually is that water cannot infiltrate into the ground anymore. It's too full, it's saturated, and therefore that water will flow over the ground and end up in rivers, which could cause them to flood. Imagine it a bit like a sponge. If you put a sponge underneath a tap, eventually that sponge would fill up with water, and it gets to a point where it can't hold anymore, and that water will either run off the top or will drip out the bottom. The second one is intense storms. So this is slightly different to the first one. Prolonged precipitation is where maybe you've got, where it rains for 4 or 5 days in a row, or it rains for 3 or 4 weeks in a row. Here we're talking about intense storms where it might just be over a period of an hour or even half an hour, where you get really heavy rainfall. And that is going to result in two things. One, it could be if you get lots of rain, maybe you have a hurricane and you have 48 hours worth of rainfall, the ground might become so saturated, you get the same problem as you did before. So you get saturation, excess overland flow. The more likely one with intense storms is where you get something we refer to infiltration overland flow. This means that the water cannot sink into the ground. You've got so much rain falling on the ground that there's just too much of it, and the ground can't cope, and the water flows over the ground. So infiltration, excess overland flow, where you've just got too much rainfall and it can't sink into the ground and it flows over the ground. It tends to happen in the UK in the summer. Another type is monsoon rainfall. Now, we studied the monsoon rains before we went into lockdown, so you should actually have some notes on what causes monsoon rainfall to happen. It's in the Indian subcontinent. It happens between around about May time, it tends to start, and it's a period of time where you just get lots of rainfall every single day. And again, as above, with prolonged precipitation and intense storms, it can lead to saturation and infiltration, excess overland flow. The next one is snowmelt. Well, we don't get a lot of snow in the UK. This tends to happen in areas where you get large accumulations of snow. So it could be in mountainous regions, the edge of the Alps, wherever it might be. And here you have large amounts of snow which might have fallen over the entire winter. So it could be the case that from December until March, you've had very cold conditions, you've had a lot of snow, it's accumulated over time and built up. And then as the temperature gets warmer, as you move into spring and into early summer, you will get huge amounts of melting of all that snow which is accumulated. And again, that can cause the ground to become saturated and you get excess overland flow. The final one is human causes. So here mainly we're focusing on urbanisation. Urbanisation is the process by which urban areas expand and grow, and they tend to involve a lot of tarmac and a lot of concrete, and that makes surfaces impermeable. Impermeable means that water cannot seep into the ground. It's going to reduce the level of infiltration that we have and also how much moisture is being stored in the soil. So the more urbanised an area is, it tends to be that when you have rainfall, you don't get water permeating into the ground, it's impermeable. The second thing to go alongside that is where you have drainage systems. Drains transport water really quickly into rivers. When water falls on your home, it will go into the gutters, it will flow down the gutters will take it into the drains might take it and they might deposit it in rivers. What that's doing is it's speeding up the process by which water enters into the channel. If you imagine we didn't have the urban environment, so there was no houses, and instead we had grass, we had trees, what would happen is that those naturally in that system, the water would fall on the trees, they would intercept it, they would absorb it, their roots would take it up. It slows the process down. If the water fell on the ground, it might infiltrate into the soils where it's stored there, or it would go into the ground and you get something called through flow, where it flows underneath through the water table. And that's kind of a really slow process. It slows down the speed that water gets into rivers. Now, the reason that's a problem is because the quicker that water can get into rivers, the more likely we are to see them flooding. It reduces the lag time, as you will have seen from the work you did on hydrographs a few weeks ago. And on the next slide, I've got a graph that helps explain that a little bit further. So this looks at the impact of urbanisation on runoff. So on the left-hand axis, you've got discharge, that's the amount of water that's in a river, and on the bottom, you've got time. And here, the graphs, we've got the red, the blue, and the green lines, each show a different drainage basin. Number one is the most urbanised. It's got a completely sewered basin with highly impervious surface, so concreted tarmac surface, and all of the sewers all over it are taking water and putting them into rivers very quickly. And you can see there that the time from which, let's say we've had a rainfall event that's happened, so it's been a downpour of rain, you can see the speed in which the water gets into the river is really quickly. So we call that the rising limb on the left-hand side. So you have a very steep rising limb, you've got a very high peak discharge, it happens very quickly, and you've got a very quick falling limb. So what's happened here is that your rainfall event has happened, so you've had a downpour of rain, and then the water has got into that river really quickly, and it's gone up really rapidly, the level of the water, because it's so highly sewered and with such impermeable surfaces that the water gets into the river really quickly. And this is at the greatest risk of flood, because if you think about the river discharge, this is how much water is in the river. Rivers can only store a certain amount of water. Let's say the banks of the river is at this point here, and we call that our bankful level or limit, then anything above that would flood. 2 here shows a completely sewered basin with natural surface. So that's saying that we've got more vegetated surfaces around. And there you can see you've still got a very quick rising limb, but the peak discharge isn't as high, and also your falling limb is a bit smoother. So you can see here that actually the flooding here has not been as problematic because of the fact you've got a natural surface. And then the final one here is natural channels and a basin surface. So it's saying it's a natural rivers, you've got natural basin surface, so you've got vegetation and grasses and trees. And what you'll notice is that your rising limb is much more angled, so it goes in much slower. Your peak discharge is much smaller, and also it goes down much smoother in terms of its falling limb. So it's spread out, the whole process takes much longer, and therefore the water goes into the river very slowly, it moves through the ground, it's intercepted by trees, it peaks at a very low level and then gradually declines again as the water gets into the river in a more slow process. So this really is just showing the fact that urbanisation can have a big impact on how quickly water gets into a river, and therefore it can also have an impact on whether or not you get flooding in a particular situation. And certainly what we're finding as we have more rainfall events, extreme rainfall events when it comes to with our changing climate, and also we see increased levels of urbanisation, that we're seeing more localised levels of flooding, and flooding in places that we've never seen flooding before. And certainly the winter we've just had from 2019 to 2020, we saw a lot of flooding events around the UK. The last one here, and I'd like to spend a bit of time drawing a diagram of this and explaining what's happening, is the impact of deforestation on runoff. I think this should be fairly self-explanatory, to be honest with you, and certainly it will be things that you've looked at before. On the left-hand side has got a picture of an undisturbed forest, which shows you with trees on the side of a hilltop. Very obviously, the trees will absorb and intercept rain. They drip water to the ground very slowly. You're also going to get evaporation and transpiration from the leaves, which means that not as much water is getting down to the ground. You've got a very large surface area within those trees and leaves. The soil is bound together by the roots of the trees, so they almost protect it and they hold it together. And you can see underground, the characteristics are very different from the degraded forest slope. So the groundwater, it's got a good store. The rainwater seeps into the forest soils. Some of it goes down into the rocks, and it's a very slow process, meaning that you don't get excess levels of saturation. On the right hand side is what we call a degraded forest slope. So degraded means that it's been changed, the trees have been removed, and now what we're finding is that the rainfall will hit the ground directly. It causes the soil to become compacted and makes it more solid. This means less rainwater can soak into the ground, and you're going to get more levels of runoff. You also quite often find in areas where trees have been removed, we're going to have grazing animals. We find that a lot in the Peak District, where we would have previously had woodland environments, where now we've got grazing stock of sheep and cows. They compact the soil down even further, which means less rainwater is going to be able to seep into the ground. Without the trees, we're obviously not getting the interception, we're not getting that water dripping down into the ground, and therefore we get a lot less groundwater. And it says there before, little rainwater soaks into the ground, so the level of groundwater is depressed and little reaches the streams. You would have thought, really, actually, if you took away trees, when it rained, the water would just sink into the ground. But that's just not the case, because you get too much rainfall falling on the ground, and therefore you get saturation, excess overland flow, infiltration, excess overland flow, all these different processes which stop the water getting into the ground. And eventually that can cause flooding to take place. There are a couple of examples on the text that I put on Show My Homework. These are actually from the revision guide for Educast, and I'd like you, underneath the diagram that you've drawn, to make some notes on the impact of deforestation and the impact it has on runoff.